Hey guys, welcome to the first section of Unit 6, and this is kind of a review. You've actually seen a lot of these concepts back in Algebra 1, but it's a pretty short lesson, and we'll just go through it here. It involves a lot of factoring and just reducing fractions. So we're simplifying rational expressions, and these are always going to be in the form of a fraction. So for our first example here, these you've done in the past for sure. Like, we are going to use the old concepts of simplifying fractions, finding common factors between the numerator and the denominator, and then just crossing those out basically. So 2 and 4, we know that 2 over 4 is the same as 1/2. The reason is because 2 is divisible by 2 and you get 1, and 4 divided by 2 gives you 2. So that's how we reduce that. The next one here, what we could do is just add up the top first. 10 plus 5 is 15. And 15 over 5 gives us 3. Pretty straightforward, nothing crazy there. Now this is the first one that we see with a variable, 6x over 12. We know that from 6 and 12 they have a common factor of 6, and if you divide those by 6 you get 1 and 2, but the x is not divisible by anything on the top and bottom, so we leave the x as just by itself on the top, and then 2 on the bottom. You can put the 1x, but 1 times x is still just x, so that doesn't really matter. Similar idea over here. This time we have variables on the top and the bottom as well as a number. So let's start with the 30 and the 18. If you think back to common factors between those two, you can take a 6 out of both of them. 30 divided by 6 is going to give us 5, and then 18 divided by 6 is going to give us 3. So we're going to have a 5 and a 3, and now we have an x squared on the top and an x cubed on the bottom. Since we have more x's on the bottom, we're going to end our answer with x's on the bottom. Specifically, we have one more x, so what you could think of this as is just 2 minus 3, which would leave us with 1 on the bottom of the fraction. Now, I'm just being picky, so I'm putting this here. You don't have to worry about that. So 5 over 3x is the most simplified version of that. Now we're going to go on to a little bit more complex of an idea. With these where you have variables on the bottom and then you're subtracting or adding between numbers, you have to be really careful. In this situation, x minus 3 over x. What we would actually do for this one is you could split this up into two fractions. You could think of this as x divided by x minus 3 over x. Now x over x, anything divided by itself is just 1, and then we would get 3 over x, because 3 and x don't have any common factors, so that's as simple as we can go. So this is actually how we could simplify that one. The next one, however, notice we have x minus 3 on the bottom, and we have 2x minus 3 on the top. This is as simple as it can go. I know that seems really weird, but we actually have 2 terms on the bottom. We can't split it up the same way that we did in the first example here of like this one here. Since there's 2 terms on the bottom separated by that minus sign, it just doesn't work to split it up the same way. So what we end up getting is this is as simple as it goes. 2x minus 3 over x minus 3. There's nothing we can take out of the top that would be reducible with the bottom. So we have to leave our answer like this. Now this next one, however, you're probably thinking to yourself, well, why can't I just take out an x minus 3? Because there's one on the top and one on the bottom. It's because this 2 here is not affecting the x and the negative 3. But now, if you look on this next problem here, we have 2x minus 6. Whenever we're doing factoring, we should always look for the GCF, greatest common factor. And notice you can take a 2 out of both of these terms. So we get x minus 3. And then the bottom, there's no GCF, so we leave it. Now here's the thing. Since we have x minus 3 multiplied by the 2, now we can cross this out, because that 2 is affecting everything in parentheses. So now our final answer ends up being 2. That might seem a little weird, but we're going to practice these. It is kind of a difficult concept to conceptualize right away. But we'll practice, it'll get better. The next one we have x squared minus 4 divided by x minus 2. With this one, what we want to do is factor the top. And you're probably going to recognize the fact that that's a difference of squares. So that's going to give us an x plus 2 and an x minus 2. And now the bottom, we have x minus 2. Since the top parts are multiplying, we can actually go ahead and consider this as a factor, this as a factor, cross them out, and we're just left with x plus 2 as our answer. Similar idea with this next one. We want to factor. That is our goal here because we want to reduce the fractions as much as possible. The top one is pretty easy to factor. We can do double parenthesis. We know x squared comes from x and x. Factors of 6 that combine to make 5, and both of the signs are plus. So we're going to get 3 and 2. Now the bottom, again, we can factor that one. That's going to be another difference of squares. It's going to be an x plus 3 and an x minus 3. Since we have an x plus 3 on the top and an x plus 3 on the bottom, we can cross those off, and we get x, well, you don't have to write it in parentheses, x plus 2 over x minus 3. That would be our answer. All right, continuing on here. This next one, again, we do have to be a little careful. 6x minus 18 over 2x. Well, try to factor out whatever you can from the top first, so we can take a 6 out of both of those, and we're left with x minus 3. And then the bottom, we have a 2 and an x. Now, this 2 can divide into that 6. It goes in there 3 times, and then 1. So what we end up getting is x minus 3 over x. Now, if you look, we actually did this problem way up here. This is actually going to end up being the same thing. The thing is, we could actually just leave our answer as this, because this answer here and this answer at the bottom are the same thing. Since there's nothing that we can't, or that we absolutely have to reduce, we could just leave this as a fraction. Like you can't factor anything more out of x minus 3 or just x. So I'm actually fine with either solution, the one we did in example 2 or the one we just got here in example 4. And I'll probably explain that better in person. Okay, and then we have x squared plus 7x plus 10 over 25 minus x squared. This one, again, what we want to do is factor out the top, double parenthesis. We get x plus 5 and x plus 2. Factors of 10, 5 and 2 that add to make 7. And then the bottom, you got to be careful because this is another difference of squares, but notice that the number is first. That actually does matter because now it's 5 and 5 to give us 25, x and x, plus and minus. Now, notice the top is x plus 5 and the bottom is 5 plus x. It works there. Those are the same thing because addition is commutative, so you can switch the order. But the subtraction, let's say that it was a minus sign, that actually wouldn't work. So we can cross off the x plus 5 and the 5 plus x. And what we're left with is x plus 2 over 5 minus x. And that is as simple as we can go with that one. All right, you're going to go ahead and try these problems for yourself and then go ahead and submit them.